Hello friends, welcome to my channel. This is Anil. So in this video, I'm going to solve numerical problems based on block diagram reduction technique. So this is the problem. So in this problem, the summing point which I have shown here that I'm going to shift before the block G3. The moment we shift the summing point, we need to draw the equivalent diagram. Okay, so this is the problem here. So this question is repeated in competitive exams. So whenever we shift the takeoff point or summing point, right, before the block or after the block, we need to focus on additional paths. Okay, this is the main forward path. Apart from this main forward path, we need to see additional forward path and additional feedback path which are connected to that particular summing point. So this is the first observation we need to do. So I have already made some rules related to shifting a takeoff point and summing point. So in that, one of the rule is, so I have the summing point here, that here, right, this summing point I am shifting before the block. So what changes I am going to observe here? If you see the output here, right, I have the input as R, so I have R times G. Suppose I give an input S, so in this forward path I have S, okay, or you can say like in this forward path I have gain as 1, okay, and here in this forward path I have gain of R into G. In forward path I have R into G. So when we shift the summing point before the block, the result should be same. If you see in this path, right, I have R into G. So in this also, in this forward path we have 1, in this forward path also I should have 1, means I need to multiply with 1 by G. So 1 by G gets cancelled with G, so I get resultant as 1. Simply remember that when we have summing point, that summing point I shifting before the block, so whatever gain G we have, that gets divided here, okay. And this, for conceptually I have explained how we got here 1 by G. As we need to cancel this G, I have taken here 1 by G. Or you can remember, the moment we shift takeoff point before the block, I need to divide the G. Same concept here. So I am shifting the summing point before the block, right? So I have here gain as G3. That whatever G3 I have, I need to divide that in additional forward path and feedback path. So this is how I written here equivalent diagram. So G1 I divided with G3, in feedback path H I divided with G3, and in the main forward path we shouldn't disturb anything. Whatever we have here, G2, G2, G4, G4, G5, G5, G3, G3. It means in main forward path we need not to do any changes. We need to do changes only in additional forward path and additional feedback path which are connected to that particular summing point only. So this is how we draw the equivalent diagram. Now coming to next problem. So this is the block diagram we have. To this block diagram, we need to find out the transfer function, output by input. So to this block diagram, numerator we are going to write the forward path, okay. In denominator, we have to focus on loops. Our other word is feedback path. So we have here one feedback path. This is the second feedback path, and this is the overall feedback path. Okay. When we consider individual feedback path or odd means we need to multiply with minus. When we take two feedback path, means 2 means even, we need to multiply with plus sign. Okay, this rules you need to remember. Now focus on numerator part. Numerator part means we need to focus on forward path. In forward path I have G1, G2, G3 and G4 and parallel. Parallel means we need to add. So G3 plus G4 into G5. So see the numerator part. I have G1, G2, then G3 plus G4 into G5. So this is what I have written here. Now coming to denominator part. First I have considered this loop. In this loop I have G2, G3 and H1. That is what I have written here, G2, G3 and H1. Since I have taken here one loop odd, I need to multiply with minus. Minus into minus plus. That is what I mentioned here. Now I take now this loop. In this loop I have elements G5 and H2. Now I need to multiply with, since it is one loop, I need to multiply with minus. Minus and minus plus. That place I have written here, and whatever elements I have here, G5 and H2, that is what I mentioned here. Now we need to focus on non-touching loops. Now this is the loop we have, right, and this is the loop we have, right. these two loops are completely separated, means there is no contact of these two loops. Technical term is non-touching loops. Okay, the moment we have non-touching loops, we need to multiply whatever elements we have in this loop and whatever elements we have in this loop, we need to multiply. Since it is two loops even, so we need to multiply with plus. Minus into minus plus, and we are taking plus, so overall we have plus. Now we need to multiply. Here we have g2, g3 and h1, g2, g3 and h1, and we have here g5 and h2, g5 and h2. So whatever elements I have, those elements I'm just keeping here, but multiplication I'm keeping here. Now I need to focus on overall loop. Okay, in this overall loop, always remember that whatever we have in numerator, that will come. Okay, what we have here numerator g1, g2, then we have g3 plus g4 into g5. Same thing we replicate here. So g1, g2, g3 plus g4 into g5. If we don't, in feedback path we don't have any elements, so into 1. So this is how we write transfer function to a particular block diagram. Hope this helps you out. Thank you.